now that we've discussed the idea of a quantitative or numerical variable, we need to go ahead and divide it off a little bit. When you look at quantitative variables, there's a number of different types of responses we can get. So for instance, if I ask you once again the number of kids you want to have, you might tell me something like, well, I don't want any kids, I want 0. Or I want 1 kid or 2. Maybe you want 3, 4, or 5 kids. Now there are a bunch of different responses you could give me, but if I compare this to, let's say I ask you exactly your height, well, you could tell me you are 62 inches tall. This is 5'2". You could tell me you are 63 inches tall, that you're 5'3". Maybe you're like me and you lie a little bit, like, yeah, I'm totally 63.5 inches tall. In fact, you could be even more specific about it, like 63.25 inches tall, or maybe 63.2221 inches tall. That is, if I really want to, I can give you more and more decimal places to it. This is in stark contrast to the number of kids you could tell me. You could tell me 0 kids, 1 kid, 2 kids, but you definitely can't tell me like 1.5 kids, or I want 1.1 children. The fact that number of kids has limited amounts of responses, that is, there are finitely many things you could choose from, is what we call discrete. A discrete quantitative variable is a quantitative variable in which I have limited numbers of options to choose from. I can say 0, 1, 2, 3, 4, 5, but I can't put anything in between that. That is, I can't put like 4.5 or 4.25. This is in contrast to height. Height is what we call a continuous variable. A continuous variable is one that has infinitely many options to choose from. That is, when I break it down, I could be 62, I could be 62.11, 62.1111. I can get more and more exact. Now it's important to realize that even though a variable might be continuous, I often don't treat it like that. So let's look at a couple examples here. Age is an example of a quantitative variable. That is, when I ask you how old you are, you give me a numerical response back. Now when I ask you how old you are, you might give me a number like, let's say, 18. But if you tell me you're 18 years old, are you exactly 18? Chances are that no, you weren't born 18 years ago on exactly this day, exactly this hour, this minute, this second, this infinitely small little measurement. So chances are you're like 18 years old, 1, 2, 3, 1, 4, 5. That is, if someone started a stopwatch at the exact second you popped out, we can know your age down to a very tiny decimal place. This ability to make our answer increasingly accurate, if A, we want to, and B, if we had the technology to do so, makes age a continuous variable. That is, in reality, even though we tend to round, we tend to represent it as discrete, it's actually a continuous variable. Let's look at another option. Let's say I wanted to talk about shoe size. So if you go to the store and you want to buy a shoe, let's talk about the options you have. Well, to begin with, you might go up and you might want a 10. And when you try on the 10, it might be too small, so you might try on an 11. And maybe the 11 is too big, so you go back down and you try on a 10.5. Let's say the 10.5 still doesn't fit. That is, the 10 is too small, the 11 is too big, 10.5 doesn't really fit either. Do you have more options you could choose from? The answer to that is no, right? There's nothing right here or right here that you could choose from. You have limited options in this. And as soon as something has limited options, that makes it discrete. So, age, continuous, I can be very exact. Shoe size, not discrete. Because even if I wanted to be more exact, I couldn't possibly do that. They don't make shoes like that. So this divides off discrete variables from continuous.